Welcome to UPSC Study Academy, empowering aspirants and shaping futures. Today, we are going to see an important topic in the science and technology domain: light. Imagine you're in a dark room and suddenly you switch on a flashlight. In an instant, the room is illuminated and you can see everything around you. But have you ever wondered what light really is? How does it travel so fast, and why does it behave the way it does? Today, we're going to explore the amazing world of light and uncover its secrets. Light is an essential form of energy and a type of electromagnetic radiation that our eyes can perceive. It consists of tiny packets of energy called photons. These photons exhibit dual nature. They behave both like particles and waves, making light an intriguing subject of study in physics. One of the most remarkable constants in nature is the speed of light. In a vacuum, light zips along at an astonishing speed of approximately 299,792,458 meters per second, about 300,000 kilometers per second. To put this in perspective, light could circle the Earth more than 7 times in just 1 second. When light travels through different materials like water or glass, it slows down slightly due to interactions with the medium's molecules, due to the material's refractive index. Light is a fundamental aspect of our universe, exhibiting a range of intriguing properties. They are wave-particle duality, speed, reflection, refraction, diffraction, interference, polarization, dispersion, absorption and emission, coherence and scattering. Wave-particle duality. Light behaves both as a wave and as a particle, a concept known as wave-particle duality. This dual nature is evident in phenomena like diffraction and the photoelectric effect. Reflection. When light hits a surface, it bounces back. This is reflection, which allows us to see objects that don't emit their own light, like the moon or a mirror. Refraction. Light bends when it passes from one medium to another, such as from air into water. This bending is called refraction and is why a straw looks bent when placed in a glass of water. Interference. When 2 or more light waves overlap, they can interfere with each other. This can create beautiful patterns of light and dark bands, known as interference patterns. Polarization. Light waves can oscillate in different directions. Polarization refers to the orientation of these oscillations. Polarized sunglasses, for example, block certain directions of light to reduce glare. Dispersion. Dispersion refers to the separation of light into its constituent colors or wavelengths when it passes through a medium. This phenomenon arises because different wavelengths of light travel at different speeds in the material. One notable example of dispersion is the creation of rainbows, where water droplets act as prisms, separating sunlight into its spectral colors. Absorption. Absorption occurs when light is absorbed by a material, transferring its energy to the material's atoms or molecules. The absorbed energy may cause electrons to transition to higher energy states within the material. This process plays a crucial role in spectroscopy, where the absorption spectra of materials provide valuable information about their composition and structure. Emission. Emission is the process by which absorbed energy is released as light. This can occur immediately, as in fluorescence, where absorbed energy is re-emitted almost instantaneously at a lower energy, or over a longer period, as in phosphorescence, where the emission of light persists after the excitation source is removed. Coherence. Coherence refers to the phase relationship between different points of a light wave. In coherent light, such as that produced by lasers, all the waves have a constant phase difference, resulting in a highly focused and powerful beam. Coherence is vital in applications ranging from holography and optical communication to precision measurements and interferometry. Scattering. Scattering is the process by which light interacts with particles or irregularities in a medium, causing it to deviate from its original path. This phenomenon occurs when light encounters particles smaller than its wavelength. Examples include Rayleigh scattering, responsible for the blue color of the sky, and Mie scattering, observed in phenomena like fog and cloud formation. The study of light branches into several fascinating fields. Optics. Optics is the broad study of light's behavior and properties. It includes geometric optics, which deals with the paths light rays take, and physical optics, which focuses on light's wave nature. Quantum optics. Quantum optics dives into the quantum mechanical aspects of light. This field explores how photons interact with atoms and molecules, leading to technologies like quantum computing and secure communication. Electromagnetic theory. This branch examines light as an electromagnetic wave. Maxwell's equations describe how electric and magnetic fields interact to produce light and other forms of electromagnetic radiation. Photometry and radiometry. Photometry measures visible light as perceived by human eyes, while radiometry measures all electromagnetic radiation, including invisible forms like infrared and ultraviolet light. Laser physics. Laser physics studies the principles and applications of lasers. Lasers emit highly focused, coherent light beams and are used in everything from cutting-edge medical procedures to everyday barcode scanners. Nonlinear optics. Nonlinear optics explores how intense light interacts with matter, leading to phenomena like second harmonic generation, where new light frequencies are created. Laws of reflection. Reflection occurs when light bounces off a surface. There are two fundamental laws governing this phenomenon. The first law of reflection. The angle of incidence, the angle between the incoming light and the normal to the surface, is equal to the angle of reflection, the angle between the reflected light and the normal. This can be expressed mathematically. Angle of incidence, theta I, equals angle off reflection, theta R. This principle explains why you can see yourself in a mirror. The light rays from your face hit the mirror and reflect back at the same angle. The second law of reflection. The incident ray, the reflected ray, and the normal to the surface all lie in the same plane. This means that the direction in which the light comes and goes, and the perpendicular line to the surface, are all coplanar. Laws of refraction. Refraction occurs when light passes from one medium to another and changes speed, bending in the process. The laws governing refraction are described by Snell's law. Snell's law relates the angles of incidence and refraction to the refractive indices of the two media. Change in speed. When light enters a denser medium, higher refractive index, it slows down and bends towards the normal. Conversely, when it enters a less dense medium, lower refractive index, it speeds up and bends away from the normal. Total internal reflection. When light travels from a denser to a less dense medium at a sufficiently high angle, it can be completely reflected back into the denser medium. This phenomenon is called total internal reflection and is the principle behind fiber optics. Have you wondered why the sky appears blue? The captivating phenomenon is due to a process called Rayleigh scattering. The Earth's atmosphere is composed of gases and particles that scatter sunlight. Rayleigh scattering occurs when light interacts with particles much smaller than its shorter wavelengths of light. Blue and violet are scattered much more than longer wavelengths, red and yellow. However, our eyes are more sensitive to blue light and less so to violet, which is also absorbed by the upper atmosphere. This results in a predominantly blue sky. During sunrise and sunset, the sun's light passes through a larger thickness of the atmosphere. This scatters shorter wavelengths out of the direct path to our eyes, allowing the longer wavelengths, reds and oranges, to dominate, creating beautiful sunrises and sunsets. And we are at the end of this video. Thank you for watching UPSC Study Academy. Like, share, subscribe, and don't forget to hit that bell button.